we are going to talk about object-oriented development. Okay. Go around the. So tell me a little bit about what background. What's your languages of choice? Is C sharp? C++. Starting on Python. Great, great. Everybody got object-oriented down, kind of understand it a little bit. Okay. Okay. Well, so I give you a little bit background about that too. So that's good. So, what is OOP and why do we care? Well, it's a way of programming that lets us organize around the objects and data rather than the actions and logic. And it's attempting to simplify really large application construction. So if and the reason because programming is really hard and expensive. But if I'm programming a bunch of different kinds of vehicles, the code for a car is different than the code for maybe a tractor, because you know speed, engine control, whatever. So you want to have an object that's a tractor that has different code than an object that's a car, and so that becomes object-oriented in a sense, right? There are some principles around object-orientedness that we try to achieve, and we use these magic names to make it easier on ourselves. And the first one, of course, is encapsulation. The idea is to hide anything we don't use. If the user doesn't have to see it, don't show it, right? So that's really what encapsulation is. Another thing we do is we strive for abstraction. Abstraction is we're trying to basically let them manipulate an object without having to actually know what it explicitly what it is doing or how it does it. Okay, so the idea is that if I have a printer, all printers in the world probably would have a method called print. Do I need to know how to set it up and all the other stuff? No, just print, good thing. And so even PDF, when you go to Acrobat, you can go to Acrobat and you can say, print this document, and you can go to the printer or you can print the PDF. Well, now the PDF code has a method that's called print, just like the other thing. And now you don't have to know explicitly how it's doing that. It just does it for you, right? And then there's this thing called polymorphism, which does two things. It allows things in a collection to have a specific behavior, to create some sort of specific behavior, so that everybody has, well, again, it's the other end of everybody has this method called print. But then it also allows you to do another thing, which is it allows a single behavior to have multiple to behave differently. So let's see, in C++, that would be, a print method that has the number of pages to print, number of copies on an argument list. But if there's nothing on the argument list, if you call print with nothing, no arguments, it just prints nothing. But if it has, yes.
I get polymorphism. I would just explain to me once that you might have a car. There's certain things that all cars do.
Yes.
And you can using inheritance, you can say car A of type A does this in addition to what all cars do. You can have a module that can be inherited from.
Right.
Using polymorphism.
Right.
Say you get from this module this set of things that this particular car can do.
But you also might get it to do that thing using very different parameters, which is the other. That right.
A might do it one way, B might do it I can see, I do it a third way,
Right,
third way.
right,
Have the car module understand all three of them.
right.
If you want. So,
Right. So let's continue on. So the tools we're going to use are things called objects, which we create from classes, and classes are like, think of them as templates. So it's like the cookie cutter, and the cookie is an instance of a class, right? I take the cookie cutter, make a cookie. Now I got an instance of that cookie cutter. Inheritance says that all cookies are made with flour, so I can make a regular cookie, and then I can embellish the cookie by adding other functionality to it, chips, raisins, whatever. And so you can have cookie cutters that build on each other. And we'll talk about that. You'll see what I mean. So let's just talk about traditional development. You might have done this in C++ or something like that, or maybe this is even before we have classes. I might have a library, and I have books in my library, I have magazines in my library, and now I have a website because I'm in the digital age. But I need to create citations for those things. And so the citation of a book might look like this over here, magazine might look like this, and a website might have that kind of information. Well, I can put all of those sources, I can declare them in a list. And like I said, the list can have anything you want in it. So in my case, it's got a dictionary of values that are different for each one of those instances, right? So when I want to process it, I have to say for some source in my sources, if the source type is a book, then I got to print it out this way. This is a print method, by the way, right? And if it's not that, then if it's a magazine, do it this way. And if it's a website, do it this way. By the way, this isn't actually legal Python, obviously, because it's kind of messed up. But anyway, but you go through all those. And so you can see that's a mess. And it's a mess because if we have a fourth type, then we got to go everywhere when we have code like this and change it. And it gets all ugly, right? This might be in hundreds of thousands of lines of code. And it would be a disaster. So in object-oriented development, what we do is we say we have objects. We have a book type object, magazine type object, and a website type object. And they all contain properties for their, like this one right here, these, for their kind of object. And they all have a print method that will then print those values. And they all derive from something we're just going to call a citable source. And a citable source has a print method on it that's exactly like the other print methods. This is inheritance. So these are going to be classes, by the way. But these classes inherit from this, which tells them, A, if you want to be a citable source, you have to implement the print citation method. So they do, okay? So that if I take these and stick them in some list someplace, I can pretty much guarantee that I have a printable citation method, I can call it, and because it would be one of these three, depending on what kind of objects in the list, it'll behave appropriately. So now my sources is the same as above, I just dotted them out. But now when I want to print my sources, I just say for source in sources, print, and it would just print. I moved all the code someplace else and out of my business logic, and it's in the implementation of each of the different types of citable object I have. And these, by the way, are just notes about encapsulation and whatnot. So terminology, we talked about classes. Classes are templates of objects. We have objects which are instances of those classes. Classes and their objects have attributes and methods. The difference will be that methods typically you'll see with parentheses, with arguments or not, and attributes typically have no parentheses. So that's a good way to tell. We talked about cookie cutters and all of that. So let's just go and make our first class. So you use the class keyword, and you give it a name, and then you end it with a colon. And like Python, all Python, the relationships to the syntax lines are represented by indentation, right? So you have to indent whatever is in there. And at the end of the last hour, we talked about the keyword pass, which is like no op. It turns out all these things that are expecting indents will not actually will be runnable from Python. And if we were in an editor, it would tell you bad syntax. So to quiet it down as we decide what we're going to do next, we usually throw in a pass, and then it just says, "Oh, okay, I can do that." And so I have that's a minimal class right there. So the next thing I do is I say, "Hey, I got a class book, and I'm going to instantiate it right here. I made it. I've got a thing called book with a lower b because case sensitive in Python, right? And I'm going to print my book, and that's what I get. I guess it should have deleted my output from last, but that's what I get. And that's just telling me basically, yeah, Python's got a book object there. And this is just something telling me that it's represented inside. But that's not important. What's important is we made a book, okay? Now let's go a step further and let's add some stuff to it. Well, one of the things we want to do is if it's a book, we have to give it the initial values of the title, the author, and the copyright year. And we need to make that print citation, right? So we're going to do that. One thing I didn't put in here, and I don't know if I do, if I wanted to have a base class that this derived from, this is where I would put the base class reference, like that. But I'm afraid to put that there because I don't have one, and because I might break it on the fly. I don't want to do that. So we're back to what we have. We're going to make a class book that's complicated. The first thing you see is an int, a nit. It's like a constructor, but it's really an initializer. The object really gets constructed. And what this does is it sets it up. So whenever you make a new one of a new book, it guarantees that this is the first thing that get called. So you can set it up. And in this case, when we set it up, we're going to give it those 3 initial values. And if you notice, all of the methods of that class have a magic first parameter. That's actually itself. So it's the this if you're C++. Okay. They just went with that syntactically, and it'll make sense later on. The difference is if it's self, it's got to be it's obviously an instance method, and if it's CLS, well then it's a class method. And I think that's the distinction. So what we do is we set up our init. We're going to set our 3 values, which we call our title, author, and copyright. Notice that I had to prefix them with word self dot. All access to the values and methods inside of the class are via the self dot. So you always have to say this, basically, if you're in C++, if you have a C++ mindset. And so we made that method. The next method we make is print citation. Pretty simple. Again, it's a instance method, so it's got a self. We already have the data inside, so all we're going to do is just print it. That's all we do. So when we make this book now with these 3 values and then call print citation, it should just print that down there. And if we rerun it, we see that it does. It prints that. Make sense? Yes.
Up into this area, but is the values of variables themselves, is there a way to make it?
Good question, because I did talk about that. That is actually a good question. So there is no such thing as private in Python. You can get at everything. By convention, if you don't want somebody to mess with your value, you're supposed to put a dash underscore. So this underscore says, don't use this value outside of the context of the object. And if you use 2 dashes or 2 underscores, it means I strongly suggest you not use this value outside of it.
I also want to add that if you put 2 underscores at the beginning, but not at the end, it changes the name to have an underscore, then the class name before the 2 underscores.
Oh, really? Okay.
Yeah, that's called private name.
Huh.
And you won't be able to use the attribute by typing the original name, type the new name. Like if you wanted to create a class that says ham dot underscore underscore spam, it'll say underscore ham underscore underscore spam.
Okay.
When you try to look up the attribute.
Okay. So we'll keep that in mind. And I think down below we've got more of that under they call them dunder, double under. So like Dunder Mifflin. I think that was actually a joke about Python. So the class above has 3 object attributes: title, author, copyright. It supports dynamic typing. These types you can find, but we put it doesn't matter what we put in these, right? So you could abuse this API by, instead of passing a string here, passing a tuple, a list, a dictionary, and really mess this guy up, right? Because the minute he hits that and then comes down here and does this print and format, it'll all get crazy and not like it. So in fact, I ran into that once. Somebody said, oh, you can pass in whatever you want, either a string or an int. Turns out in one method in this implementation, you can pass a string. In the other implementation, you could pass the int. But you couldn't use things consistently on the outside of his API because he was using them in such a way that it would break. I said it's not really constructor, but it's guaranteed to get called at the beginning. I think that's what that's about. There are 2 methods, right? Under an int, which is that special method. And in fact, Python is rife with special methods for all sorts of things. I could take any kind of class I want, turn it into an iterable object by implementing methods. I can create scope behavior using using under methods. But there are 2 methods here, right? The print method, constructor method, and they are instance methods because you get to them using the self argument. And as I said, all methods and variables in a class are accessed via self. And here's your privacy model question. Underscores have special meaning in Python tactically. Discouraged. Yes, single underscores discouraged, double underscores severely, strongly discouraged. Hard notion. There is no hard notion of public and private. However, I have noticed that certain tools will ignore the under methods when processing some of your code, so that you don't accidentally pull things in. It's probably honoring that suggestion. Yes, and of course, like I said, these forbidden functions will get called. So now let's talk about, that was an instance method. Let's talk about class methods. Remember, classes have to come first. You have to define a class, and then you can instantiate and make objects, instances, which I showed you how you can call methods on. Now we're going to go back and we're going to create a class method. And the only difference here is I'm using the @class method decorator, and which these things are really great. Learn how to do decorators, which we're not going to talk about. But the word class. So all references to the class are via this. So you can make a class singleton, right? You could make a class level object or attribute, a class level attribute. I want to make it constant. Be careful, but so anyway, here I am. Class. The classes have special things like here's name, so I can get the name of the class under method. I'm using it And we do use a lot of things like that. Just don't change them. I don't think you can. Maybe you can. Because we just got done saying that the use of this outside of the context of it's not a good thing. And of course, we're inside the context inside. So that's good. But we said, okay, this is a class method. Why is this and that? Oh, we'll talk about it. Apparently, I put that in. So what's going on here? Well, in this case, you can set the private attribute yourself. Here, for instance, there's no public or private. So I just set it and I can print it. I can print the name of the book. I can print the citation type. Oh, this is the class. This is the instance. So I'm printing an instance of a book. Here I'm saying the citation type of this book is going to be a magazine, and I'm printing it. So it's a magazine. And then for the book class method, I type book. They're both book because one is the class, one is the instance, and the citation type, again, class and instance. Instance is going to control. It's going to be control. I'm not sure why that does. Okay, somebody here know what I'm doing? I forgot. Okay, we're gonna gloss over that. I think you got the major things, and maybe the text will talk. So citation type. Is a class attribute. We talked about that. And it's private, but remember, you can still get to it. So that is a class attribute, but it's not private. Print name is class method. Class methods may be invoked either by a class or by the object itself. Class methods receive a reference to the classes they belong to when they're called. So this class method always gets a CLS, but I can call it from an instance. And Python will then go figure out the class and I can have static class methods like print citation type, which is static. They may be invoked by either the class or the object class. They don't receive a reference to the class when they're called. So that's really the only big difference between them. So this is, I could just, it's not really associated with this, but I'll call it. I don't get any information whatsoever, but things can happen. So that's what that was about. So let's talk about inheritance. So this is now my class citable source that we were talking about way at the beginning when we looked at the picture. And I'm going to set the next citable source number because we want them indexed, right? We want each person to have a different catalog number, for instance, in a library. And they have to be initialized. So when I initialize, I want to go out and I want to grab the next number, set it to the number of the object I'm creating, and then calculate what the next number would be. So every time we make a new object that's implementing citable source, I want to give it a new instance number, incremented by 1. Does that make sense? You would never probably do it this way, but we're just illustrating the class features. Okay, and of course, one of the things you're going to want to do is you're going to want to get the number. So anybody who implements this base class or inherits from this base class will want to get the number that was assigned. And of course, you want to be able to print the number, which if you don't do anything, if you don't implement a print citation method in your derived class, you'll get this base implementation. So this is the fallback. Okay, and then we're going to make a class that's unknown but derived from citable source. probably to demonstrate that this is the method that gets called. We'll make a book that's citable source that has this input. Yep.
I think you can use the super keyword in place of citable source dot init.
You can.
Super dot init
You can.
to call from a derived class.
Yep, you can. This is how you initialize a book, the print of the book, we've done that. Here's the version for the magazine. What we're going to do here is I'm going to make an unknown, which doesn't really have any derived implementation. And then we're going to make a book and a magazine, and we're going to print the citations of each and see how they come out. They should come out like that right down there. And just make sure, to make me honest, we'll run it again, and we get exactly the same thing. Does that make sense? So let's highlight the inheritance issue. You indicate it by putting parentheses and the name of the base class there. The default base class constructor will be called unless it is explicitly called when inheriting from the base class. So, no, really, what I want to that should say is that if you say magazine, you're going to get this and it. If you want to initialize the base, the base class, you have to call it, which is the super, as this gentleman said. You can access the base attribute methods by either the self or class, depending on what's going on. And we talked about the fallback position, that there's a base class implementation of citation, print citation. So the base class made this default so that if this one weren't here, it would have called that one. That makes sense too? Now we're going to talk about a thing called duck typing and why classes may not be all that useful, depending on how big a problem you have. If it walks like a duck, swims like a duck, quacks like a duck, it's a duck. And some aspects of the object orientedness are achieved using different mechanisms than class hierarchies. So here I am. I'm saying I got a class unknown that has a print citation, a book that has a print citation, a magazine that says I have a print citation. They don't derive from any base class. It really doesn't matter, because as long as they all use the same consistent name, you can just call the print citation. So in a sense, you don't have to have a huge number of complex class hierarchies in the code. And does that make sense? Because it's a dynamic language, it's by name, it doesn't matter. You don't get default behavior, right? Base class default behavior is going to occur, but maybe you don't care. It also means you can do weird things, like you can attach a function to another object and call it, and it becomes, you can adopt it. So that's another weird thing. Citations is a list of our citations, each citation constructed in place. This doesn't care. It doesn't care about the class type or anything. The dynamic, we talked about. So let's talk about the special methods. There is a whole host of special names. Okay. So this document, it's on my website or on my Git repository, lists all of the different special methods that you can use to implement, that Python then leverages to make your objects behave in a certain way. Going back to here. So let's just talk about one. I don't know if anybody's ever seen the with keyword. The way this works is in C++ or whatever, if you construct something not on this, not on this, not on the, not on the heap, but on the stack. When you leave scope, it destroys it, calls it delete. You're done, right? Well, that doesn't happen in Python, but you can make that happen. And the way that happens is you use with. So I'm going to open files are they're an expensive resource. There aren't that many of them, right? File handles in the OS. So you want to open and close them when you're done with them, right? So the way that you can make that happen is you can say, open this file, and I'm going to call that file F, which is this, and then I'm going to use that F inside the scope. And when I'm done, I want you to clean up after. I want you to close the file. What happens is when you do something and you enter the scope, when you enter the scope, where is it? Yeah, right here. But if you have this implemented on your method or on your object or whatever, then it will call that. So when I open the file, it says, oh, open has this method called enter, under enter, and I'm going to call it and do my thing, set everything up. Now I drop down into scope, everything's great. When I leave, I'm going to call exit. It goes, oh, now I'm leaving, so I'll do all the cleanup. And it all just magically happens for you. So we could create a class, which is what we're going to do, called timer, that does much the same thing. And in this example, we're going to create a timer that we can use in scope. So we have an init that says start and end time will just be set to 0, always going to have start and end. You can declare your variables anywhere. So I could make start only happen in enter if I want. You know, I can move these assignments down to enter. But I like to put them in init because I'm guaranteed that all the variables will have some reasonable number. Because if you use them before you set them, bad things happen. So at least this way they're all set, something sane. So when I enter what's going to happen when I enter scope, it's going to figure out what the start time is. And then it's going to return self because it has to. That's the rule of the enter function. And then when I exit, I get some stuff that I'm not using here, but you get traceback information and things that you may want, may not want, whatever. I've never used them. I've only used this a little bit. And I'm going to calculate the current time, subtract the start time, and that's the difference. And I'll print it. So whenever this goes into scope, it's going to calculate what the time is. It's going to sleep for 2 seconds. And then it's going to come out of scope because that's the next execution line. And it'll tell me how long I've been in there, which should be around 2 seconds. Right? And that is, of course, equivalent to doing this, which was construct a timer, call the enter, sleep 2 seconds, and then exit. And this syntax is much prettier and whatever. So you can see what happened in the last run. There's the first one. There's the second one. They basically did the same thing. So you've created a new thing within Python in the sense that now there's a timer, and you can put this off in some module and load it when you want it. I didn't do that.
God's dramatic.
Say that again.
Is only called when you use with. The enter method, is that only called when you use the with?
Yes. Yes.
It's called, like, follow those little special function. Like in the case of any, you will notice that if you want to create special actions, and this makes it. Makes them special. A lot of people don't understand this. Is they begin and end all magic, all these magic methods begin and end with a double underscore.
Right, but that's only special because that's what the Python people chose, right?
Yeah.
They could have made it double ats. You know, it's
We call them double, we call them Dunder.
Dunder methods, yeah,
Double underscore.
right. And so in fact, init is a double under method, right? These things here print string representations of whatever you have. So you can have a complex class and then have a print method for it, basically. You just put your method, you can put your object in a print statement. And the print statement is going to go, does this object have a method called stir or repper? And if it does, then it uses it, renders it, and you get it, it comes out, and you don't have to do anything special. So now your code just looks like print my object, done. You can, like I said, you can turn an object into an iterator. So if you create these methods here, all of a sudden now you can say for X in some weird class you made. In fact, that's what range does, right? Range is a method if you were in the first hour. It's an iterator object, say for X in range, parentheses 0, 10, a parenthesis, which says basically go from 0 to 9. Yes.
You can also do a single number where it'll start from 0.
By
You can also
default.
type- By default, it's 0. but-
Yes. Well, look, you're saying you could say just range 10 and it goes from 0 to 10 and 0 to
0 to
9.
9.
Yeah.
Because it never returns the high value.
Right, right.
That's a use. Under a nit. You do that manipulation under a nit. You automatically set the begin.
Yeah.
0. The nit, if it doesn't provide it.
So you can make properties, you can make methods look like a property. So you could have a property that gets calculated whenever anybody calls, and the property would be extracted via these methods here. If you want to make a you want to make a class look like a function. So if this is an instance, you just want to call it, boom, it's just a call. So whenever Python sees this nonsense, it says, oh, is there a method on this called dunder call? And if there is, then call it. And then down here, you've got, oh, you want to know what the length of something is, but it doesn't inherently have any kind of concept of length, but you have some weird concept that you want to implement, you can just dunder len, and now you can do it. And as far as contains, same thing. So you can make something look like a dictionary. You can make things look like numbers so that they behave with pluses and adds and multiplies and divides and all that other crazy stuff. More the same, even more of the same. Oh, here's all your comparisons, right? No, what is this? Oh, negation, absolute, type conversion, blah, 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 all that kind of crazy stuff.
That's
Here's
how
your
the
comparison.
text-
Yeah.
I don't even see it. Unless you really want.
Serialization. By the way, there's a thing called pickling in Python. You can take an object and pickle it, make it a file, and then load it back in later on and manipulate it.
I was just looking and I saw that in addition to reduce EX, there's also get new args EX.
Okay. And there's, yeah, we're definitely fine. Enter and exit with, oh, this is our width right here, right? Then really historic stuff like, oh, how to calculate the hash. So let's say you want to, I told you some of these things use hashes. So you can mess around with the hash, how it's calculated. So you can make A and B the same if you want. That'd be kind of perverse.
Sorry.
Yeah, I know, but you could do it. So you could index something with the character A and then with the character B and get the same value. Because you perversely just reassigned the hashes. So it'd have to be an object. I don't know if you can manipulate the characters that are in the system. But yeah, there's all kinds of that's really kind of how Python gets object oriented. I don't see a huge number of classes in the packages that I've jumped around in. I see more of that kind of stuff.
Yes, I understand it correctly. Kind of groups of things
Yeah,
that
yeah,
are together, but you don't wanna.
but like
The
facial
example-
recognition,
the
yeah,
example is how you would build an email. How
right,
you build an email,
right,
there are multiple modules within the package email. And each one does a function.
mm-hmm, mm-hmm. So let's get back to our text because we're gonna be on AMA soon. So why is the one better than the other? Well, because it's shorter. Shorter is always better. It's easier to read and understand. Its interpretation is clearer. And if you forget to call the exit, well then you're screwed, right? Because now your timer's just gonna keep running. If your printer's gonna stay online, your file's gonna stay open, and then you can't reopen it later. All that kind of stuff. Pardon?
You can forget the enter and this will up gets fixed.
Yeah, there you go. Well, yeah, that there are exceptions, and I didn't go over them. There are exceptions. Nothing spectacularly different. Yeah. Yeah.
How it's put together.
So okay, let's go over the last little bit. Polymorphism is a little bit hard, and the reason and we didn't go over it yet. And all this is talking about is, oh, we're going to now talk about this. How do we get a single behavior out of many different circumstances? I.e., I want to call the same method, but I want to call it with different arguments. And there's a couple ways to do that. One is you can make everything name value and then just have them all default. That's a mess. But then there's this thing called args and kwargs. I'm going to just paraphrase all this. Args is I'm going to give you a list and their positional and their values, apply them. And this kwargs is I'm going to give you a dictionary of key value pairs, and the keys are the values I want you to apply them to, and the values of those values to put them. And we'll show you. So this is purely positional, right? You're going to call this with arg1, 2, and 3, and you're just going to print them out. Okay. Now, if I do this, I basically have created a tuple, right? And the tuple has 3 values in it, and I can pass them in like this. Now, that little star there is kind of a magic way of saying, I want you to unpack these values. So that's the args part of args and kwargs. So if we run it, which probably already did, we did. There, see, this is this. This is the method we made, and we called it, and we got the arguments that we expected, right? So that's a way of passing in something that now, if I go like this, well, let's not do that because that would be bad. If I have less, if I do that, it should be okay. Oh, what's wrong? What did I do wrong?
I think I know what.
Nope, it doesn't like that. So this way you have to have exactly the same positional arguments.
I think I got a good explanation of what that's all about. Yeah, I get the concept of. Normally have a fixed number of arguments.
Right.
So you might have some where you say in the call, K
Oh,
equals
sounds
something.
Thank you.
That is a car. K are keyword argument.
Is that?
The other, the
That.
other, the other two position, example of are.
Right, right. Okay,
There are two types of things you can ask to a function.
right. Lists and art and dictionaries. Yes, yes, and I talk about that. Go ahead.
Well, actually, you can still pass them arguments with a default value as an R, not a keyword R, but if you don't pass that R, it will just give its default value.
Right, as long as I made that, the minute I made this default, it was okay for me to call it with only two arguments. And I could have done that anyway. So I'm sitting here going, well, if I could do that, why not just do it? When we get down here farther, it becomes more interesting. So let's get into that. So this is a quarks. This is the same as parameters on the call, right? We test args. We could have just called that, yes. Now we're going to go down here to quarks. Now we're keyword arguments, and we're going to call it with this. And when we call this, think of the star as unpacking a dictionary, kind of. And when we call it, we get the same thing. But now I should be able to also, because there's no notion of number of arguments anymore. Now when I call that, what?
Mix the two. What you did is put a positional, you have to put all the positional arguments and all the name defined arguments together. You can't say positional, keyword, positional, doesn't allow.
And this doesn't do what I thought it did.
That's what that explosion is.
Well, this doesn't do what I thought it would do. Anyways, I'm not even gonna talk about that because I don't know what I'm talking about. We're gonna go to here. So now supposedly we can create a constructor that will give us the ability to pass in whatever we want. So here I am, I say, oh, the book is gonna have title, author, copyright. Sometimes the book will just have title. And and so I do, that's what I didn't do. We didn't change that. We need to change it on that end too. So this is an instance of quarks that actually should work. Yes. So we put the quarks on the receiving function. And we can say, hey, if quarks has a title, then the title will be whatever that is. Otherwise, it'll be none. By the way, this is an inline if, right? And so if it's not there, I get none. If it is there, I get the value. And then down here, I'm just going to call this and say, oh, well, the title is this, the author is that, the copyright's this. That'll work that way. Oh, I only know the title, so the others are none. And now that does kind of what I was trying to do. Ta-da. And that was it.
I read that line right. So it's like the forms bracket title, if title in forms, that's all one expression. And so it's like that. No, go back before the else.
Okay.
So it's like from the forms title, if title in forms, that's all one expression, which could be the value if it's true.
So it's X. It gets this value if
right.
If title is in quarks. Else it gets this value.
Of course, it's all of the.
Right, yeah, that part I understand. I'm trying to figure out how the how that if works. So it's the quarks bracket title sort of attached to the if.
Yeah, it is. Yeah.
That's the true part of the if.
Yeah, you normally you would do this, and this would fail abysmally if there was no title. But because this is here, it says, oh, well, wait a minute, no. We're only gonna use that value if there's a title in quarks. Otherwise,
So I guess that was covered in the first time.
Yes.
It's kind of like the question mark and colon in C++ for Java.
yes,
But they didn't want to do that because of Python's creator, Guido van Rossa, choosing that syntax for 2.5.
yes.
He got caught up with all the long, tracebacks that kept happening to people. When I made that particular mistake that described.
A lot of things get chosen
Yeah,
in the
before-
language because somebody hates something else.
Also, before that, they would use expression and on true or on false, but that can work. That won't work when the expression is false, like if you're print, because print returns none. So we always go to on false. So it's always better to use on true if expression, else on false.
So this concludes my craziness. How's it going? Anybody got any questions? General?